The world runs on physics, from you sitting or standing watching this video to the astronauts using physics to go around the moon. And yet, physics is so difficult to understand. Circular motion, for example. What is it? What are some examples of it? And how can we demonstrate it through an experiment? Now, while I go find the answer to that last question, I'll let you learn the other two. There are many examples of circular motion in our lives, like ice skaters spinning, merry-go-rounds, and even elevator brakes. But how do these objects in circular motion actually work? Let's find out. This is the equation for the velocity of an object in circular motion. While right now it just looks like a bunch of letters, we can use the following diagram to show what the letters represent. R is the radius of the ball from the center of the circle that it's moving in. In our diagram, that's the length of the rope. V is the velocity of the ball, aka how fast it's going. 2 pi is how we calculate the circumference of the circle from the radius. Last but not least, P is the amount of time it takes for the ball to go around the circle once. You might see that we want this equation to equal P, not V. Luckily, that's an easy thing to do. If we multiply by P and divide by V, we end up switching the two letters in our equation. Now we can plug in our numbers and see that it takes about 6.3 seconds for the ball to go around the circle once. If we look back at our previous examples, we see that people increase and decrease their radius of rotation. Let's see what happens when we do the same thing to our model. Let's make r half of its previous value. We'll keep all the other values the same, and if we calculate how many seconds it would take to go around the circle with half the radius, we'll see that it only takes half the time. Similarly, if we make r double its original value, then it goes twice as slow instead of fast. That's why in circular motion, you should decrease your radius if you want to go faster and increase it if you want to go slower. Welcome back. I found an experiment we can do. We can decrease and increase the radius of our circular motion by walking to the center and outskirts of this merry-go-round while it's spinning. Now we should see an increase in rotational speed when I'm at the center and a decrease when I'm on the outskirts. But do keep in mind that the world is slightly more complicated. This merry-go-round is heavy and likely has a non-insignificant amount of friction with the ground. This will make the change in speed less dramatic, but it should still show if you pay attention. Congratulations! Now you know how circular motion works. Go and see what other experiments you can do to demonstrate this part of physics. And remember, whatever you do, you're doing physics.